first step in Gauss method is that we have to build an equation Ax equal to b in form of augmented matrix. In this case, all the three linear equations have to be translated into augmented matrix, like I show in this video. So the second step is we are using elementary row operation to reduce augmented matrix to form a reduced augmented matrix RAM. So how to identify that we are already form a reduced augmented matrix is the 3 on the left bottom is 0, like I show in this video.
For the first step, our target is to make the lower triangle to be 0, which is 2, 3 and 4. So we need to keep the first row untouchable. The second row, we use the equation 2R2 minus R1 to change our target, which is 2, to be 0. And all of the numbers in the second row will be multiplied by 2 and reduced with R1. We use the equation 4R3 minus 3R1 to the third row, as we need to change 3 into 0, as well as the numbers in the third row will multiply by 4 and minus by 3R1. We obtain the second augmented matrix as shown in the slide. Then, our next target is to make 1 in the third row into 0. So we use the equation R3 minus R2. Third row, negative 8z is equal to negative 40 can be simplified into z equal to 5. From the first row, we can obtain the value of x by insert z equal to 5 into the equation. So, x is equal to 6. The last one, from the second row, we can obtain the value of y by insert z equal to 5. Thus, the value of y is 3, z is equal to 5, and x is equal to 6. This system of linear equation has unique solution. For example number 1, the equation given is negative 3x minus 5y plus 36x equal to 10, negative x plus 7z equals to 5, and the last equation given is x plus y minus 10z is equal to negative 4. So firstly, we should change the equation into augmented matrix that have been shown in the slide. So this is the augmented matrix. So the next step is we need to change the lower triangle of the augmented matrix into the 0. For the next step, our target is to make the lower triangle to be 0, which is negative 1, 1 and 1. So we need to stay the first row of the augmented matrix as untouchable. Next, we use the equation 3R2 minus R1 for the second row to make negative 1 to be 0. So all the numbers in the R2 will be multiplied by 3 and minus by R1. Next equation we use is R3 plus R2. It means that all the R3 numbers will be plus by R2. Next, we use the equation 5R3 minus R2 to make the last one to be 0. So, we obtain that the third row, all the third row be a 0 numbers. So, we conclude that this system of linear equation has infinite solution. Example number 2, the equation given is x plus y plus z equals to 2, y minus 3z equals to 1, and 2x plus y plus 5z equal to 0. So for the first step, we need to change the equation into the augmented matrix like this. So reminder to all, the lower triangle of the augmented matrix must be 0. For the next step, we want to change 2 and 1 into 0. So we use the equation R3 minus 2R1. All of the numbers in the third row will be minus by 2R1. For the next equation, we use R3 plus R2 to make negative 1 to be 0. So we obtain that 0x plus 0y plus 0z is equal to negative 3. It is impossible for 0 to be negative to equal to -3. Thus, this system of linear equation has no solution.